No, it is not allowed to install circuits from a UPS and an emergency generator panel in the same raceway. The emergency generator and the UPS feed separate systems. The generator provides backup power in case of a power outage, while the UPS provides power protection to sensitive loads and ensures continuity during temporary interruptions. They are considered separate systems, even if they are both feeding the same panel. Therefore, the circuits from the UPS and the panel cannot be installed in the same raceway. To understand why this is the case, it's important to consider the distinct roles and requirements of emergency power systems and uninterruptible power supplies. Emergency power systems, such as those powered by generators, are designed to provide backup power during prolonged utility outages. These systems are typically governed by specific codes and standards that emphasize reliability and safety during emergency situations. The National Electrical Code, or NEC, Article 700 addresses emergency systems. The NEC defines an emergency system as a system intended to supply, distribute, and control electricity for illumination, power, and signaling essential for safety to human life. These systems are required where automatic illumination, power, or signaling is necessary for life safety. These systems are designed to provide power for a legally required standby system or an optional standby system when the normal power supply fails. Typical examples of where emergency systems are installed are hospitals, fire stations, police stations, and other public safety facilities. UPS systems, on the other hand, are designed to provide continuous power to critical loads during brief power interruptions or fluctuations. UPS systems typically use batteries to provide power when the normal power supply is interrupted. These systems are designed to protect sensitive electronic equipment from voltage sags, surges, and other power quality issues. The NEC addresses UPS systems in Article 645. UPS systems are often used in data centers, computer rooms, and other areas where even a brief power interruption can cause significant disruption or data loss. There are several reasons why it's important to keep emergency power and UPS circuits separate. Firstly, emergency power systems are subject to different code requirements than UPS systems. Emergency power systems must be designed and installed to meet stringent requirements for reliability, redundancy, and safety. These requirements may include features such as automatic transfer switches, backup generators, and fire-rated wiring. UPS systems, on the other hand, may not be subject to the same stringent requirements. Secondly, emergency power systems and UPS systems serve different purposes. Emergency power systems are designed to provide backup power during prolonged outages, while UPS systems are designed to provide continuous power during brief interruptions. Mixing these circuits could compromise the performance of either system. For example, if an emergency generator fails to start, the UPS system may be unable to provide power to the connected loads for the duration of the outage. Similarly, if the UPS system fails, the emergency generator may not be able to start quickly enough to prevent a brief power interruption. Thirdly, mixing emergency power and UPS circuits can create safety hazards. If a fault occurs in one circuit, it could potentially affect the other circuit, leading to a fire or electric shock hazard. For example, if a short circuit occurs in the UPS system, it could trip the breaker for the emergency power system, causing a complete loss of power. Furthermore, the different characteristics of emergency power and UPS systems can create compatibility issues. Emergency generators typically produce a sinusoidal waveform, while UPS systems may produce a modified sinusoidal waveform. Connecting these systems to the same circuit could cause harmonic distortion or other power quality problems. In addition to the NEC requirements, there may be other local codes or regulations that prohibit mixing emergency power and UPS circuits. It's important to consult with a qualified electrical engineer or inspector to ensure that all applicable codes and regulations are followed. Here are some specific NEC articles that are relevant to this topic. NEC Article 700 covers emergency systems. This article provides requirements for the design, installation, and testing of emergency power systems. It includes requirements for automatic transfer switches, generators, and other components of emergency power systems. NEC Article 701 covers legally required standby systems. These systems are similar to emergency systems, but they are not required by law for life safety. They are typically used to provide backup power for essential business operations. NEC Article 702 covers optional standby systems. These systems are not required by law and are not essential for life safety or business operations. They are typically used to provide backup power for convenience or comfort. NEC Article 645 covers information technology equipment. This article provides requirements for the installation of power and grounding systems for information technology equipment, including UPS systems. It includes requirements for isolated ground circuits, surge protection, and other power quality measures. In summary, circuits from UPS and emergency generator panels must not share a raceway due to different code requirements, distinct operational purposes, potential safety hazards, and possible compatibility issues. Always consult with qualified professionals and adhere to the NEC and local regulations to ensure safe and compliant electrical installations. When designing and installing electrical systems involving emergency generators and UPS, there are several best practices to consider. Firstly, ensure proper separation of systems. Maintain physical separation between emergency power and UPS systems, including separate raceways, panels, and transfer switches. This helps prevent interference and ensures that each system can operate independently. Secondly, use appropriately rated equipment. Select equipment such as wiring, conduit, and overcurrent protection devices that are appropriately rated for the intended application. Emergency power systems may require higher ampacity ratings and more robust construction than UPS systems. Thirdly, implement proper grounding and bonding. Grounding and bonding are critical for safety and performance. Ensure that both the emergency power and UPS systems are properly grounded and bonded to minimize the risk of electrical shock and prevent equipment damage. Fourthly, perform regular maintenance and testing. Regularly inspect and test emergency power and UPS systems to ensure that they are operating properly. This includes testing generators, batteries, transfer switches, and other components. Keep detailed records of maintenance and testing activities. Fifthly, provide adequate ventilation and cooling. Emergency generators and UPS systems can generate significant heat. Ensure that these systems are installed in well-ventilated areas and that adequate cooling is provided to prevent overheating and equipment failure. Sixthly, install surge protection. Install surge protection devices on both the emergency power and UPS systems to protect sensitive electronic equipment from voltage surges and spikes. Surge protection is especially important in areas with frequent lightning storms or other power quality issues. Seventhly, consider redundancy. For critical applications, consider implementing redundant emergency power and UPS systems. This can provide an extra layer of protection against power outages and equipment failures. Eighthly, provide clear labeling and documentation. Clearly label all components of the emergency power and UPS systems, including panels, circuits, and transfer switches. Provide detailed documentation, including wiring diagrams, equipment specifications, and operating procedures. Ninthly, train personnel. Train personnel on the proper operation and maintenance of emergency power and UPS systems. This includes training on how to start and stop generators, how to monitor battery status, and how to troubleshoot common problems. Tenthly, comply with all applicable codes and standards. Ensure that all installations comply with the NEC local building codes and other applicable standards. Consult with qualified electrical engineers and inspectors to ensure compliance. By following these best practices, you can ensure that emergency power and UPS systems are installed and operated safely and reliably. This can help protect critical equipment and prevent disruptions to essential services. In addition to the technical aspects of emergency power and UPS systems, it's also important to consider the human factor. During a power outage, it's important to have a plan in place to ensure the safety and well-being of occupants. This plan should include procedures for evacuating the building, providing emergency lighting, and communicating with emergency responders. It's also important to have a backup communications system in place, such as a two-way radio or satellite phone, in case the normal communication system fails. Regular drills and training exercises can help prepare occupants for a power outage and ensure that they know what to do in an emergency. By addressing both the technical and human aspects of emergency preparedness, you can create a more resilient and safer environment. Remember that electrical codes and regulations are constantly evolving. It is important to stay up to date on the latest changes and consult with qualified professionals to ensure compliance. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical engineer or inspector before making any decisions about electrical installations. Ignoring these regulations could lead to unsafe conditions, equipment damage, and legal liabilities. Therefore, prioritize safety and compliance in all electrical work.